Oh, okay, you guys, we are going to finish this up. We're going to do page 2. So that was page 1. Hopefully you watched that, or if you didn't need to, great. Here's page 2. So, oh goodness, there we go. So number 26, we are here we need to add like terms, And if you think of the radical as your variables, you need to make sure that they are exactly the same. So for example, the square root of 3x is not the same as the square root of 75x. The square root of 3x would be the same as the square root of 3x. The square root of the cube root of 3x is not the same as the square root of 3x. So they have to be identical. Same index and same radicand. So just make sure that you understand that you have to have them be the same. Okay, so that being said, what I can do though is look at 75 and say, all right, that looks like something I can simplify. So if I start off with 5 3x minus, and I take the square root of 75x, I can simplify this to 25 times 2, right? Which is the square root of 5 square root of 2x, which is still not the same. I multiply that 5 times the 3 because there's that 3 out here that comes down, and I multiply them. So 3 times 5 is 15, 2x, and that is as good as it gets right there. And if I look at my answer sheet, I'm going to look and see, is that somewhere on there? And I don't see it. I wonder. That. Let me see. Oh, because that's not right. That doesn't multiply. That multiplies to be 50. So that's wrong. This would actually be 75 is 25 times 3. So then that would be 3. So then now they would be. Oops, sorry guys. So now I've got 3x. Now I can combine the coefficients. And I get negative 10, 3x. And there is my answer. Okay. Now, just like, because if you think about this would be 5 if you had the variable y as your 3x minus, 15y, then you would just subtract the coefficients and get negative 10y. So same idea, okay? All right. Now, number 27, again, none of these are the same, but I need to simplify 50, and here is 25 times 2. I was just not thinking. So then that would be 5 times 5, or you could say the square root of 25 is 5. So you bring down that 9, you multiply by that 5, and I leave the 2 inside. Minus 5 square root of 8. That's going to be 4 and 2. And again, I could say the square root of 4 is 2. So minus 5 times 2 square root of 2 plus the square root of 48. This is going to be 16 and 3. The square root of 16 is 4, and then leave the 3 inside. So then I've got 45 square root of 2 minus 10 square root of 2 plus 4 square root of 3. And at this point, I see that these are like terms. This is not like those. So I can combine those and get 35 square root of 2 plus 4 square root of 3. I can't do anything more than that. That's as simplified as it gets. So there you go. All right, number 29. Now I've got 6x with the cube root of 5x plus 2 cube root of 40x to the 4th. All right, so I need 3 of the same things. This is as simplified as it gets. This, however, is going to be 5 times 8. 8 we know is 2 times 2 times 2. So we'd have 6x cubed 5x plus, this is going to stay in, these are going to come out. So 2 times 2 is going to give me 4x, well, and then I can leave the 5 in here. And then x, 3 of them come out as 1, and 1 of them stays in as x. Now, keep in mind, please, please, please hear me when I say everything after the coefficient has to be exactly the same, must be exact, exactly the same to combine your coefficients. So then when I combine those, I'm going to get 6 plus 4 is 10x cube root 5x. And there is my answer. Okay. And that should be on there. Yep. All right. Last in this section, we've got the cube root of negative 125, x to the 10th, y to the 12th. This is easy compared to the ones that we've just been doing. This, of course, is 5 times 5 times 5, but not just 5, but negative 5. And keep in mind, since we have an odd index, we can have a negative. So we pull the negative 5 out. 10 divided by 3 is x to the 3rd power with 1 left over. And 12 divided by 3 is 4 with none left over. And there we have it. And then we check and make sure, and sure enough, boom. All right. That's the end of that section. Now, find the domain. When you think about domain, remember, when you have a even radical, this number must be positive or 0. So whatever's in here has to be greater than or equal to 0. If I have an odd index, then this number can be any number, okay? So in this situation, I've got an index of 2, so 12 minus x must be greater than or equal to 0. So then you just solve that. Subtract 12 from both sides, negative x greater than or equal to negative 12. I'm going to divide by a negative number, so I'm going to flip the sign, and I get positive 12. Okay, so x has to be less than or equal to 12. And on a number line, here's 12. It would have to be less than or equal to. So there you go. Now this one, though, it's a cube root, which means that any of the numbers, this can be positive or negative. So my domain would be all real numbers. All real numbers. There's no restrictions on what x can be. Here, x cannot be 13 because then that would create a negative number under there and that won't work. Anything above 12 is going to create a negative number under there, and it doesn't work. All right. And for graphing purposes, your graph would look like that. Literally, if you go to Desmos and graph this equation, you'd see. All right. What about evaluating this for h of 9? You just plug in 9 equals x. So the square root of 3 times 9 minus 2, h of 9 would equal. So h of 9 equals the square root of 25. So that would equal 5. Now, it's not plus or minus 5 because if we were graphing it, again, when h is 9, there's only one answer. It's not like it's a quadratic, okay? Now in this, we're gonna do, what is h of 9? The cube root of 2 times 9 plus 9 is gonna be the cube root of 18 plus 9 is 27, and that's gonna be 3. So that is the evaluating of 9. There's that. Moving on, I'm just going to do these really quick. So these are super important. These 7 questions are probably most like what you're going to find on the test. So if you can't do these, hopefully you can do them after you watch the video, but make sure that you can do these on your own without help, without assistance, without photomath, without anything, without even watching the video. Watch the video, change some numbers, and see if you can solve it. So here we've got this. We can change that to the cube root of 16a to the 5th over the cube root of b to the 12th. This is going to be 2a cube root 2a squared all over b to the 4th. Hopefully you can see where I get that. This is 8 times 2. 8 is the cube root. 2 is the cube root of 8. 3 goes into 5 once, and I'm left with 2. Moving on, this is going to be the cube root of 3 over the cube root of 2a squared. Now, I have to rationalize this denominator. This one just worked itself out because this was a perfect cube. This one is not a perfect cube. So I need to rationalize this denominator, which means I need to multiply by something that's going to get rid of this. I need 3 2's. There's only 1 2. So I need to multiply by 4. I need 3 a's. There are 2 a's. So I need to multiply by 1. Cube root. 4a cube root. Now, when I multiply these out, 2 times 4 is 8. The cube root of 8 is 2. A squared times a is a to the a cubed. Cube root of a cubed is a. Done. Now I can multiply these and I get the cube root of 12a. Now, can I simplify 12? Well, 12 I can write as 2 times 2 times 3. There's not 3 of a kind, so that's as simplified as it gets. Moving on. This, I think we just did this problem. So this is 6x cube root 5x, that stays the same. This we can change to 2 times 2x cube root of 5x. And then we add those together and get 10x cube root 5x. Because 2 times 2 is 4x cube root of 5x. And as you'll see, this and this are exactly the same. So if I wrote all of this down, maybe that'll help you if you're struggling to see. This, and I get 10x cube root 5x. Moving on. Now I need to add these. The first thing I need to do is rationalize this denominator. So I'm going to take 5x divided by 2 and change that to the square root of 5x divided by the square root of 2. What do I need to multiply by? Well, this is a square root, so I need 2 2's. I have 1 2, so if I multiply by another 2, I should be fine, and I'm going to get square root of 10x over 2. So that's what I get here. 10x over 2 plus the square root of 10x. Now, keep in mind that my coefficient here is 1/2. This can be rewritten as 1/2 10x, and this can be rewritten as 2/2 10x if you need to see it that way, right? Your coefficient here is 1. I can rewrite 1 as 2 2. Then I add 1 plus 2, and I get 3/2 square root of 10x, or 3 square root of 10x over 2. Both of those would be legitimate answers. Moving on. Now here I'm foiling. And keep in mind, I don't have the exact same binomials. So do not just multiply the first and multiply the last. One is plus, one is minus, that is true. But they're not the same. So don't fall into that trap because it will be wrong every time. All right. So I'm going to multiply the 9 times the 5, get 45. X squared times the square root of x times the square root of x is x. Then I'm going to multiply that by this, negative 27 square root of x plus 10 square root of x minus 6. And now I can combine my like terms. These are going to be my like terms. So I'm going to get 45x minus 17 square root of x minus 6. And boom. And now here, I cannot just multiply by the square root of 7 over the square root of 7 because I would get 3 square root of 7. If you try and do that, don't do that. So we're going to multiply by the conjugate. Remember that? And that is basically the exact same binomial except for minus instead of plus. So square root of 7 minus 3. Now I distribute that 8 to both. So I get 8 square root of 7 minus 24 in the numerator. Then I FOIL these. And if you want to do it this way, just to make sure these would cancel out, I'd get 7 plus 9, which is 16. Now, this is beautiful, except I do see 4 divides into 8, 4 divides into 24, 4 divides into 16. So there's a couple ways to do that. You can factor out the 4 and get 2 square root of 7 minus 6 over 4 times 4. Now, one thing you might be saying is, Ms. Lavelle, you could actually factor out an 8. I could, absolutely. But since I'm only factoring out 4 is because that's what divides evenly into the denominator. And then I'm left with 2 square root of 7 minus 6. I can factor out whatever it is that will factor. So the other way to do that is if I were to factor out an 8. Like this. Then 8 goes into 16. Oh, 2 times. What am I thinking? So yeah, you should factor out an 8. Goodness. Square root of 7 minus 3 over 2. That's the right answer. Holy mackerel. Moving on. And last but not least, I've got can't really tell. I think that that's divided by. So I think that this is 8x divided by the square root of 3x divided by the square root of x. I believe that that is what that is. And if that's the case, that's fine. This is basically the square root of 3 times the square root of x divided by the square root of x. Those can cancel out. So then I'm left with just the square root of 3. Because you go ahead and simplify this as best you can first, then kind of work with it over here. So now I've got to get rid of that denominator, the radical. And I'm going to have 8x square root of 3 over 3. And there is the answer to that. Okay. And moving on, we're almost done. The back here, we'll do these problems next, so we don't have to worry about those right now. We're going to do those next after this test. Rationalize the denominator and simplify further. So these are kind of important because we got 2x over 3y cubed. This is cubed 2x over cube root 3y. I need 3 of these, so I need to multiply by 9y squared. Why 9y squared? Because I can rewrite 9y squared as 3 squared y squared, if that makes it easier for you to see. Notice these are exactly the same. I just rewrote the 3 squared as a 9 up here, and I just wrote the 9 as a 3 squared down here. They're the exact same number. But now you can see I've got 3 3s and 3 y's. So when I multiply them out, I'm going to get cube root of 18xy squared all over 3y. Now, I've told you over and over again, which hopefully you've heard, if you have the numerator and the denominator the same variable, you need to simplify. The only difference is since we are using the radical and not exponentials, rational exponents, we can leave it like this because this is inside the radical, this is outside the radical. So this is a perfectly fine answer with the radical. If there were rational exponents, then we would need to change that out. So if this was 18 to the 1/3, x to the 1/3, y to the 2/3 over 3y, I would need to reduce that to 18 or 6. Nope, 18 to the 1/3, because I can't do that because those are not the same. X to the 1/3, and then 3y to the 1/3, because that would be a negative exponent, right? 2/3 minus 3/3, which equals -1. So that would be my y. Y to the 2/3 minus 1. All right, oops. There you go. So this is what it would look like in rational exponent form. This is what it would look like in radical form. Moving on, if that confused you, I'm sorry. If it confused you, just ignore that. It's just working this in rational exponent form, although you shouldn't need to know that, actually. Moving on, we've got 3u squared divided by the 4th root of 8u cubed. Now, let me show you. I need 4 of the same numbers. I don't care what numbers it is. I just need 4 of the same to take up this. I know that 8 can be rewritten as the 4th root of 2 cubed, u cubed. So then I just actually need 1 more 2 and 1 more u. I don't know if you can see that, but then I'm going to get 3u squared, 4th root of 2u all over 2u, right? Because then I'd get 16u to the fourth in the fourth root, which is 2u. And then I can simplify that to 3u fourth root of 2u over 2. And there you go. This one, you're going to need the conjugate because we have a binomial. We've got two numbers connected with a plus or a minus, so we need the conjugate. So this is going to be 3 square root of 2 plus the square root of 3. 3 square root of 2 plus the square root of 3. And then we multiply them out. This multiplied by this is going to be not, oh wait, let's do the numerator first. 6 square root of 2. 2 times 3 is 6, square root of 2, plus 2 square root of 3. Then 3 square root of 2 times 3 square root of 2 is going to be 9 times 2, right? Minus, you would FOIL, but we know that the middle term is going to cancel out because we are getting the conjugate. So negative 3x, or negative square root of 3 times positive square root of 3 is going to be minus 3. So this would be 6 square root of 2 plus 2 square root of 3. All over 18 minus 3 is 15. Now, I could reduce that, but I can't reduce this one, so I have to leave it just like that. Even if I were to factor out a 2, 2 does not evenly divide into 15. All right. And last is this one. 3 plus square root of 5 over square root of 2 minus 1. I need to do the conjugate. So that's going to be square root of 2 plus 1, square root of 2 plus 1. Then when I work these out, I need to FOIL these, right? 3 square root of 2 plus 3 plus square root of 10, because 5 square root of 5 times square root of 2 is square root of 10, plus square root of 5. That's a lot of square roots at the top. We don't care. Square root of 2 times square root of 2 is 2. Negative 1 times, or yeah, positive 1 is 1. So our denominator is 1, which is great because that just means our answer is going to be our numerator. And then I can combine my like terms. There really is nothing to combine. So really, there's your answer. Okay, that's it for the review. Hopefully that's helpful. Bye, guys.